Hello everyone, I'm Gayatri Pamulapati. Today I'm going to talk about ADTA, Deep Learning with Big Data Final Project. The contents of the project are Introduction, CIFR 10 dataset, Build, Train and Test CNN on CIFR dataset, Compare Convolutional Neural Network Performance, Improve Convolution Neural Network Performance, Project Report. The CFR dataset consists of 60,000 color pictures, each with a pixel resolution of 32 into 32. The dataset consists of many classes, with each class containing 6,000 instances, resulting in a total of 60,000 photos. The dataset was partitioned into two subsets, with 50,000 photos allocated for training and 10,000 images reserved for testing processes. The dataset is downloaded using the provided URL on the Canvas platform. Once the dataset has been acquired, the Google Cloud platform may be initialized to start the deployment of a virtual server. Build, train, and test CNN on CFR dataset. The study aims to compare the performance. Coming to build, train, and test CNN on CFR dataset. The study aims to compare the performance of the convolutional neural network model on two different datasets, namely the MIAST dataset and the CFR10 dataset. The evaluation metric used for this comparison is the test accuracy, specifically at the 50 data points. The approach involved obtaining the maximum test accuracies for each of the convolutional neural network models and calculating the discrepancy between the datasets by computing the difference. CNN design. Based on the previously indicated architecture, when the input data has been loaded, it is subjected to a process for rearrangement through the utilization of one-hot encoding. The image data is sent into the convolutional layer, which is then allowed by the creation of training and testing sets consisting of pictures and their respective labels. Following this, the waiting times will be initialized and the bias will be saved. Subsequently, the dot product operation will be performed and the resulting data will be input into the pooling layer. The aforementioned procedure will be iterated by establishing a connection with the convolutional layer and afterwards advancing the pooling layer. After the final outputs have been obtained, the loss function and softmax cross entropy loss function will be computed. The aforementioned computations will be forwarded to the dense layer in order to facilitate the training process of the neural network. Furthermore, the inclusion of epoch in the process allows for the calculation of step accuracy at regular intervals of 100 steps, which is then documented in the findings. Based on the preceding findings, it is evident that the accuracy rate stands at 12% during step 0 and subsequently decreases to 49% by step 300. In a comparable manner, the accuracy during each step will progressively improve until it reaches a maximum value, after which it remains constant for the steps being executed. Based on the findings derived from the model testing, it was noted that the accuracy exhibited a progressive increase as the number of steps rose. However, this pattern was only sometimes seen throughout the testing process. as the accuracy experienced an exponential fall after reaching its peak value of around 55%. The test accuracy then decreased to 20%, mainly as a result of the model overfitting due to an excessive number of steps performed on the validation split data. Underfitting may occur as a result of inadequate data, which hinders the neural network's ability to train effectively. Based on the findings derived from the model testing, it was noted that the accuracy exhibited a progressive increase as the number of steps rose. However, this pattern was only sometimes seen throughout the testing process, as the accuracy experienced an exponential fall after reaching its peak value of around 55%. The test accuracy then decreased an exponential fall after reaching its peak value of around 55%. The test accuracy then decreased to 20%, mainly as a result of the model overfitting due to an excessive number of steps performed on the validation split data. Underfitting may occur as a result of inadequate data, which hinders the neural network's ability to train effectively. If we see the document over, we can say that to obtain a CFR dataset, initially it is essential to acquire the data from the Canvas platform. After obtaining the data, initiate a remote virtual server using Google Cloud Platform is possible. To gain access to the server, it is necessary to begin an SSH session by clicking on the chevron adjacent to the SSH option and choosing the Open a new browser. Then once the GCP SSH session is initiated within the home directory, it is possible to observe a comprehensive listing of the items within the guide or folder using the command ls. After ensuring that all the necessary criteria are met, generating a novel subdirectory within the JP and located in the home directory is imperative. To do this task, one may navigate to the drop-down menu by clicking on the arrow symbol and afterward choose the upload file function. Therefore, they will be uploaded to the designated home directory. Subsequently, it is essential to replicate the data files that have been submitted by employing the cp command. The command mentioned above duplicates the data files and saves them in a designated folder. The command provided may be used to copy all pertinent files to the specified subdirectory, as indicated in the inquiry. We may readily utilize the dataset for our scholarly investigations by adhering to the prescribed procedures. And coming to the build, train, and test, the initial step involved creating directories and transferring data to the virtual machine instance. Subsequently, a pathway was established enable the importation and unpickling of data for further manipulation inside the dataset. Following my previous statements, I emphasize the need for supporting functions for the other 7 data files, all of which pertain to metadata. The training dataset consists of 5 batches, whereas the testing data consists of 1 collection. The initial stage of constructing a convolutional neural network entails the establishment of placeholders to accommodate input data. Obtaining the necessity for reshaping, subsequently the first convolutional layer is created. followed by the second conventional layer incorporating the recruited liner unit and pooling layers. The data is then reshaped and flattened to facilitate the transmission into the initially fully connected layer. Lastly, a dropout layer is introduced subsequently following the generation of outputs, the establishment of the loss function, and the computation of the softmax cross entropy loss. A dropout layer and a final fully connected layer are incorporated. Ultimately, we establish the process of acquiring knowledge, create an optimization mechanism, and formulate a training framework. In the second part of our study, we proceeded to develop a series of procedural steps, gather data points, and evaluate the model's performance by executing the code block 100 times to determine the accuracy of the matches between the predicted values and the real values. Subsequently, we convert the gains from integers to TensorFlow float32 data type and proceed to compute the overall accuracy, and the model is evaluated at iteration 100. In this part, the objective was to construct a conventional neural network and import the dataset. The dataset was then prepared for model training, followed by training the model using TensorFlow without employing cursors. Finally, the accuracy of the model was accessed. Below is a comprehensive system schematic illustrating sequential arrangement of distinct constituents and elements with a conventional neural network implemented in TensorFlow. Based on the findings derived from the model testing, it was noted that the accuracy exhibited a progressive increase as the number of steps rose. However, this trend was only sometimes seen throughout the testing process, as the accuracy after that experienced an exponential fall after reaching its peak value of around 55%. The test accuracy has a decline, going a weight of 20%. The decrease may be mostly attributable to the model overfitting due to the excessive number of steps taken against the validation split data. This study aims to compare the performance of the conventional neural network model on two different datasets, namely the MNIST dataset and the CIFAR dataset. The comparison is based on the test accuracy achieved by the model at 50 data points. In comparing the performance of the NMIST CNN with the CFR CNN model, it was observed that the former exhibited better accuracy. In conclusion, several variables attributed to the significant variance shown in the data. Overfitting is a phenomenon seen in the CNN model which may have decreased accuracy ratings. Underfitting occurs when the dataset used for training is insufficient in size or fails to adequately reflect the test set, resulting in suboptimal performance. The data needs more regularization. The settings needed to be adequately adjusted, resulting in suboptimal test accuracies. And when comparing a conventional neural network, neural networks are a class of feed-forward neural networks that utilize filters and pooling layers to extract significant features from input data. In contrast, recurrent neural networks include a feedback mechanism by directly feeding back into its own structure. Conventional neural networks maintain a consistent size for both the input and output dimensions. A conventional network is specifically engineered to analyze images with a fixed dimension and produce a predicted class label for each image, along with an associated level of confidence. Is characterized by its smaller size compared to the CFR dataset. which therefore affects the accuracy of models trained